Good day, grade 7. How are you today? Okay, sounds great. Today, I am going to discuss about identifying the problem and formulating a hypothesis. Scientists are problem seekers. They ask researchable questions and state them in a clear, specific, and testable way. The first step in a scientific investigation is identification of the problem. The problem serves as the foundation of an investigation. Thus, it should be well defined to initiate a good scientific investigation. When a problem is identified, a tentative answer to it, a hypothesis, is then formulated. A hypothesis can be stated in two ways. We have null hypothesis and alternative hypothesis. Null hypothesis is the negative way, states that changing the factor being tested will have an effect on the result, while alternative hypothesis is the positive way. It states that changing the factor being tested will have an effect on the result. For example, if one is studying the effect of fertilizer on plant growth, here are the possible hypotheses. For null hypothesis, applying fertilizer does not affect plant growth. For alternative hypothesis, applying fertilizer improves plant growth. A hypothesis may not always be the answer to the identified problem. To support or refuse a hypothesis, an experiment must be designed and conducted. When a hypothesis holds true for numerous similar experiments, it becomes a theory. Experimenting, observing, and gathering data. The value and success of a scientific investigation depend on careful planning before conducting an experiment. Experimentation is regarded as a cause and effect test between two variables. It aims to generate evidence to answer the problem to be solved. It involves identifying the experimental variables, making operational definitions of the terms and conditions to be used in the experiment, and outlining the experimental procedure. Data acquisition or data gathering is an essential task in scientific investigation. It involves not just simple collection and recording of data, but also the science process skills such as measuring, classifying, and comparing. Properly gathered data help establish experimental results as reliable and valid. Lastly, making conclusions. Making conclusions begins with interpreting the gathered data. Raw data are processed and organized into more concise and meaningful statements about the identified problems. Conclusions based on findings are drawn. A conclusion, therefore, is a direct response to the problem under investigation. Furthermore, it should state whether the initial hypothesis for the problem is accepted or rejected. Please read concepts at a glance, and after that, answer the following activities. Direction. Fill out the following graphic organizer below after reading the concept at a glance. That's all for today. Thank you for your listening and for your active participation.